Hi students, welcome to MC Square Chemistry video classes. In this video class, we are going to discuss about second year intermediate model paper. In this particular video, we will discuss about very short answers which have come in the model paper of intermediate board, right? Question to answer one by one we will discuss. The first question has given that what is relative lowering of vapor pressure, right? Anyone can expect this question, right? What is relative lowering of vapor pressure? You listen about that as RLVP. What is relative lowering of vapor pressure? So everybody know that what is lowering of vapor pressure, and even you know that what is vapor pressure. So when vapor pressure decreases because of a non-volatile solute in the solution, that is called lowering of vapor pressure. Due to the presence of non-volatile solute in the solution, vapor pressure decreases. That is called lowering of vapor pressure. Relative lowering of vapor pressure means, we'll just write the formula. Relative lowering of vapor pressure, RLVP, is equal to PO minus PS by PO. This is called relative lowering of vapor pressure. Here PO minus PS is lowering of vapor pressure of a solution containing non-volatile solute. PO is what? PO is vapor pressure of pure solvent. The ratio is called what? RLVP. That is our answer. So you can say that the ratio of, I told you that PO minus PS is lowering of vapor pressure, right? So the ratio of lowering of vapor pressure, and I told you that lowering of vapor pressure in which solution? The solution which containing non-volatile solute, correct? So the ratio of lowering of vapor pressure of a solution containing, that solution containing what? Non-volatile solute, containing non-volatile solute. So this is 2. Ratio of what and what? This and this to the vapor pressure. Again vapor pressure of a pure solvent is known as relative lowering vapor pressure. Right? The ratio of, here the ratio of lowering of vapor pressure means what? That is PO minus PS. Okay, to the non-volatile solute, to the vapor pressure means what here? PO. So both the ratios is called what? RLVP. Relative lowering of vapor pressure. The ratio of lowering of vapor pressure of a solution containing non-volatile solute to the vapor pressure of pure solvent is known as RLVP, that is relative lowering vapor pressure. The next question given that, give 2 examples for zero order reactions. So this question has come from chemical kinetics. Okay, so the second question, give 2 examples. Just we have to write the examples for those are important, that for first order and zero order. Most of the times they ask you that give examples for zero or first order reactions. So in this question paper he asked that give examples for zero order reaction. This question from chemical kinetics. Just write 2 examples. For each example 1 mark you will get. Okay, first example, the famous example Haber's process you can write. Okay, that ammonia gas will give nitrogen gas plus hydrogen gas. To balance this hydrogen, we are taking here 2NH3. Here 2 3s are 6, that is why here 3. Correct? So what we are doing here, catalyst is here 2NH3 gives rise to iron, right? Iron. Next one, we may use that platinum also. Platinum. We are heating this. This is one example. The next example is what? This is also famous example, hydrogen iodide. Hydrogen iodide gas will give hydrogen gas as well as iodine gas. Both of them are gaseous reactions only. Here that catalyst is Rm, that is gold, and we are heating this. These are the two examples. He just asking that give two examples for zero order reaction. That is ammonia is giving nitrogen and hydrogen iodide gas is giving hydrogen and iodine. For each one you will get 1 mark. Okay. The third question we'll discuss. The third question is, give the composition of the following alloys. Okay. Give the composition of following alloys. Composition means what? Means that alloy. First of all, alloy is what? Alloy is a combination of metals, more than 2 metals, or metals with non-metals also. That is called alloy. So he is asking some alloys and asking in that particular alloy, what are the metals or non-metals present in that? Okay. Give the composition. Give the composition of the following alloys. The following alloys. So the alloy is given that the first one, you can expect that most of the times, several times they asked it. First one asked brass. Second one is bronze. And third one they asked you that German silver. German silver. So we have to write what are the metals it has or non-metals it has. At the same time, what is the composition of them, means which percentage they have. German silver. Okay. So we know that brass is containing what? Brass is containing zinc and copper, right? The combination of copper and zinc is nothing but brass. Bronze is what? The combination of copper and tin is called bronze. And next, German silver is what? The combination of copper, zinc and nickel. So what is the composition? We have to write. So in the brass, copper percentage here, and one more is what I told, zinc. Copper plus zinc. How much percentage of copper is there? Here the copper is present that 80 to 90%. 80 to 90%. Okay. And zinc is remaining part. That is what? 10 to 20%. 10 to 20%. That is the composition of copper. Copper 80 to 90% and zinc is 10 to 20%. If you see that bronze is containing, I told that copper and tin. Copper and tin. So how much copper is there? Copper, and one more is what? Tin. Copper and tin. Tin is what? Sn. Symbol is Sn. So copper is here 75 to 90%. The remaining part is what? 10 to 25%. So this is the bronze composition. Bronze composition. Finally, German silver containing what? Copper, zinc and nickel. That you have to write. Copper, zinc and nickel. So copper plus zinc plus nickel. All the three are present. So how much copper is present here? The copper is present here 50 to 60%. Just you have to remember. There is no logic to remember in that. You have to memorize them. 50 to 60. Zinc 20 to 30%, and nickel 10 to 20%. You have to practice it. You have to memorize it. Okay. Give the composition of the following alloys: brass, bronze, and German silver. So these are the composition percentages which are present in the different type of alloys. So the fourth question: what happens when phosphorus is heated? What happens when phosphorus is heated? Okay. So this question, phosphorus means this question from P block elements is asking that. Try to read the question, because answer, half of the answer is in that only. What happens when white phosphorus is heated with concentrated NaOH solution, and the condition also he has given in the question itself. What is the condition? In an inert atmosphere of carbon dioxide, CO2, carbon dioxide. What happens when white phosphorus is heated? White phosphorus, you can take the symbol of phosphorus, tetraatomic phosphorus, and we have to add concentrated NaOH. So NaOH solution means obviously it is containing some water. We have to add water also. Then what will come, we have to write, and the equation you should write. Okay. So look at the question. Half of the answer in that question only. So when white phosphorus, I am starting there. White phosphorus is heated, as it is I am writing, is heated with concentrated NaOH solution, in an inert, as it is I am writing the question, inert atmosphere. Inert atmosphere of CO2 means that atmosphere we created, that it won't react with carbon dioxide. That reaction, carbon dioxide will not affect the reaction. Okay, that is called atmosphere, inert atmosphere of carbon dioxide, to produce the product I am writing now, to produce phosphine. Phosphine means what? Hydrate of phosphorus. Hydrate of phosphorus is phosphine. Hydrate of nitrogen is ammonia. Like that, hydrate of phosphorus is phosphine. So the same question I wrote. White phosphorus is heated with concentrated NaOH solution in the inert atmosphere of carbon dioxide to produce phosphine. For this, we have to write the equation. That is important. Definitely you should write the equation. Even you write the equation also, you may get the marks, right? So for this 1 mark and the equation 1 mark. Phosphorus, white phosphorus, and he gave that NaOH solution, concentrated NaOH solution. Solution means it contains what? Water. And I told you that it is heated, heating symbol. And product is what? PH3 phosphine plus sodium phosphite. Sodium phosphite also will come. NaH2PO2. Phosphorus reacting with sodium hydroxide and giving that phosphine. Okay. So this is called phosphine. This one is called sodium sodium hypophosphite. Sodium hypophosphite. And of course, this is the phosphorus. Okay. So it is not balanced. So to balance that, here 4 phosphorus are there. Here I am taking 3 phosphorus. And 3 phosphorus and 1 phosphorus, total 4. And hydrogens here, 3 2s are 6 plus 3, 9 are there. Here 3 sodiums are there. First I am writing that 3 sodiums. Now here 3 hydrogens are there. Here total 9 hydrogens are there. Okay. To make that equal, we are writing here 3. Right? Everything are balanced, right? So when white phosphorus is heated with concentrated NaOH solution in an inert atmosphere of carbon dioxide to produce phosphine. So that is the equation. Okay. The next question given that, how is chlorine manufactured by DEACONS method? That is the next question. How is chlorine prepared by DEACONS method or DEACONS method? Very, very important question, which we expect already. So better to concentrate on that. Preparation. I'm not writing the complete question now. Preparation of chlorine. Preparation of chlorine by DEACONS method. DEACONS method. So he is asking you that how will you prepare chlorine by DEACONS method? That is the question. That the subheading only the question. Preparation of chlorine by DEACONS method. So how will you prepare chlorine by DEACONS method? So here the gaseous hydrogen chloride we have to take. Gaseous hydrogen chloride, which undergoes oxidation in the presence of CuCl2, right? Cupric chloride. Hydrogen chloride gas reacting with oxygen means that is called oxidation. In the presence of catalyst is what? CuCl2, and the temperature 723 Kelvin, you will get chlorine, and byproduct is what? Water. Okay. So here we have taken hydrogen chloride gas, oxygen gas. We got chlorine gas. Of course, this is the liquid. So to balance that, here 2 chlorines are there. If you keep here 2 means hydrogens are balanced, but oxygens are not balanced. So that is we take here 4 Cl. So here 2 Cl2. Here 4 hydrogens. So 2 H2O. Hydrogen chloride gas undergoes oxidation with atmospheric oxygen, means this oxygen is present in the atmosphere in the presence of catalyst cupric chloride at the temperature of 723 Kelvin is called DEACONS method, right? So you can write whatever we discussed, that the gaseous hydrogen chloride, the gaseous hydrogen chloride undergoes means reacts with oxygen is nothing but what? Oxidation, right? So undergoes oxidation, you can write oxidation with atmospheric oxygen, means oxygen which is present in the atmosphere. Atmospheric oxygen in the presence of catalyst, in the presence of CuCl2 catalyst, and temperature also you have to mention at 723 Kelvin gives, what is giving? Chlorine. Gives chlorine. This is the statement. Okay, means just I wrote that statement based on that equation. The gaseous hydrogen chloride undergoes oxidation with atmospheric oxygen in the presence of CuCl2 catalyst at 723 Kelvin gives chlorine. Okay, that's about 5th question. Now the next question. The next question has come from metallurgy. That is general principles of metallurgy. The topic is there, right? From that, he has given one question. So that question is, what is MISC metal? Give its composition and use. What is MISC metal? Give its composition and use. Okay. Sixth question. What is MISC metal? MISC metal. Give its composition. Give its composition and use. Right? So many model papers have this question. Right? One of the important question. What is MISC metal? Give its composition and use. So MISC metal definition and composition combined we are going to write. Right? This is one alloy. Alloy means what? Mixture of metals. More number of two or more number of metals or non-metals is called MISC metal, right? So we can say that we can start with alloy. The alloy of composition I am writing 95% lanthanoid metals, lanthanoid metal, 95% lanthanoid metal, comma 5% nearly, right? Not exactly, nearly 95%, here nearly 5% iron, and still some traces means very few amount, traces of sulfur, carbon, so non-metals, correct? Aluminum, calcium is called MISC metal. So we define this MISC metal based on its composition only. So what is MISC metal has come and what is composition also has come. Now remaining is what? Use. It is very strong alloy. That is why it is used to prepare bullet shell. So that bullet always containing some shell. You have watched, I think, in so many movies, right? Whenever they firing, that bullet shell is falling down, right? That shells are prepared by this MISC alloy. And one more, lighter flints. So whatever the lighter, it may be to use in the kitchen or to take smoking. Smokers also have containing that lighter, right? So that fuel is burning by one splinter. That splinter also prepared by this MISC metal. So use, you can write that the magnesium based means it is another mixture of MISC metal is containing magnesium also. The magnesium based alloy of MISC metal is used in shells of bullet and lighter splint. That's it. That is the use. So MISC metal means 95%, nearly 95% lanthanoid, nearly 5% iron, traces of sulfur, carbon, aluminum, calcium, that is MISC metal. It is used in, that is magnesium based alloy. Magnesium based alloy is used to prepare the shells of bullet and a lighter splint. Okay. The next question, expected question. In the exam also we can expect this question from the polymers. Now you got what is that question, right? So the question is given that what is PHBV? How is it useful to man? Okay. What is PHBV? What is PHBV? How is it useful to man? PHBV is a polymer. correct? Which polymer? That is one copolymer. Copolymer means combination of monomers is called copolymer. PHBV. So we can define this. We can start with that copolymer only. So the copolymer of, so that what are that compounds present in the PHB, we have to write the copolymer of 3-hydroxy. So usually when we are writing the complete form of PHBV, that we will write that as beta. Here we are writing that 3-hydroxy. So 3-hydroxy butanoic acid. 3-hydroxy butanoic acid and 3-hydroxy again. Butanoic means it contains 4 carbon and one more is 5 carbons, means what? Pentanoic acid. So the copolymer of 3-hydroxy butanoic acid and 3-hydroxy pentanoic acid is known as PHBV. The full form of PHBV also you have to write in the exam. PHBV means here simple, very simple. Here 3-hydroxy is there, right? You can write polybeta-hydroxy. Polybeta-hydroxy butyric. Polybeta-hydroxy butyric. In the place of butanoic, we are writing butyric. Right? 3-beta-hydroxy butyric. Butyrate. Polybeta-hydroxy butyrate. Co-beta-hydroxy means copolymer of valerate. Very important. Definitely you should write this. Polybeta-hydroxy butyrate, co-beta-hydroxy valerate. Practice it so many times. Okay, this is called PHBV. And the use of this also, you know that it is used in medicinal industry to prepare capsules and some orthopedic devices also we can prepare. So you can write that used in medicinal industry. Used in medicinal industry to prepare capsules, and one more is what? Orthopedic devices. Still so many uses are there. Even it is biodegradable, right? Degraded by bacteria also. So we can use that prevention of environment also. But we can write only one use, that is sufficient to get the 2 marks. The copolymer of 3-hydroxy butanoic acid and 3-hydroxy pentanoic acid is called PHBV. PHBV full form is what? Polybeta-hydroxy butyrate, co-beta-hydroxy valerate. And use is what? The use of PHBV is mainly in the medicinal industry to prepare capsules and as well as orthopedic devices. Okay, that's about PHBV. So obviously we can expect the next question from the polymer only, right? The next question he asked that, what is PDI? What is PDI? That is called polydispersity index. Okay, what is PDI? So we asked PHBV as well as PDI. So PDI full form is what? Polydispersity index. I will write the formula, then you can tell the answer. Okay, that PDI is equal to MW bar by MN bar. This is called PDI. Okay, PDI. So what is MW bar and what is MN bar? If you know, you can write the answer, correct? The ratio of MW bar and MN bar. MW means weight average molecular mass. N for number, W for weight. Number average, weight average. Okay, that is called polydispersity index. Polydispersity index. Okay, so the ratio, you can write that the ratio between I told you that W means weight, so the ratio between weight average molecular mass, and N for number, I told number average molecular mass, weight average molecular mass and number average molecular mass of a polymer is known as PDI, polydispersity index. The ratio, not ration, the ratio between weight average molecular mass, I told that what? MW bar. And number average molecular mass, MN bar of a polymer is known as PDI, polydispersity index. Okay, we'll go for the next question, 9th question. So the 9th question has come, 9th and 10th, both of them have come from chemistry in everyday life. So the 9th question is, what are analgesics? How are they classified? Okay, 9th question, what are analgesics? And he is asking you that we have to write the definition as well as how are they classified. The classification also you should write. How are they classified? You know that analgesic word you listen so many times. Analgesics means the tablets or the drugs or the chemical compounds which reduce the pain. Okay, those are called what? Analgesics. So you can write that same. The drugs or chemical compounds, you can write the drugs which used to reduce or totally remove the pain. The drugs which used to reduce or totally remove the pain. So here, whenever we are using, some side effects are there, right? Yes or no? Some side effects are there. When side effects are there means those are called as another type again. Okay, so you can say simply the drugs which used to reduce or totally remove the pain without causing any side effects. Are called side effects. Means what? Whenever we are using some drugs, we may get some mental confusion, right? And some disturbance in the nervous system and drowsiness, like that, side effects. So side effects are not there, called analgesics. So the drugs which used to reduce or totally remove the pain will be removed. Okay, and he didn't ask any example, that is why no need to write. And how are they classified? That you should write. These are classified as, what is that? Number one, narcotic, and one more, second one, non-narcotic. narcotic and non-narcotic analgesics. Narcotic analgesics and as well as non-narcotic analgesics. So for classification also 1 mark and definition also 1 mark. So definitely should write. Okay. The drugs which used to reduce or totally remove the pain without causing any side effect. Right. And the last question. So whenever you got 2 marks from chemistry and everyday life means obviously 1 more also will get from for 2 marks only. Why? Because that chapter carries 4 marks, 1 4-mark question or 2 2 marks question, right? So the last question given that what are antiseptics? Give examples. Okay. Last question. What are antiseptics? What are antiseptics? Give examples. Give examples. So this also, you listened about that antiseptics we used also. For example, Dettol. Dettol is antiseptic, right? We can apply on the skin. When we have wounds or cuts also we can apply. Those are called as antiseptics. So the combination of this question is disinfectants. The difference is what? Both of them will reduce the microorganism, growth of the microorganism, but one will apply on the living tissues, another one is apply on the non-living tissues. Okay. So we can say that the drugs are the chemical compounds. The chemical compounds which prevent or kill the growth means completely they prevent, or those drugs will kill of microorganisms. And one more point I should add here. Even you can write this also, nothing will happen. The chemical compounds which prevent or kill the growth of microorganisms and can apply on living tissues. Can I apply on living tissues? Right. So I told you just now that skin, wounds and cuts, for that we can use, are called antiseptic. Is nothing but which stop the septic. Septic is because of what? Microorganisms. So we have to stop the growth of microorganisms, right? So living tissues are called antiseptics. Example. Just now I told you that example, Dettol. And you may write a tincture. It is called tincture of iodine, correct? Tincture of iodine. These are the examples for antiseptics, which are killing or which are prevent the growth of microorganisms. Those are known as antiseptics, right? So that's about very short answers which has come from the model paper of intermediate board.